Now we have reached the last part of the material in consumer behavior. And we're going to conclude this part by understanding what happens when consumers can make mistakes and how to model this. Now, this material is essential to be able to understand the limitations and the scope of everything that we have done, in particular, when do the previous models are likely to apply well, and in what domains, in what circumstances do we need to worry about the issues, mistakes, and second, to think about some applications like addiction or marketing when the issue of consumer mistakes is actually quite critical. Here is a very simple way of thinking about models with consumer mistakes. The model has 4 elements. First, we need to make a distinction between 2 types of utility functions. One type of utility function that I'm going to call decision utility, and one type of utility function that we have encountered before that I'm going to call experience utility. And let's denote this function by U of du for decision utility, and this one by U of EU for experience utility. Now, this function is the one that explains the level of welfare, well-being, hedonics that you actually experience, the consumer actually experience, based on how much it consumes of goods X and M. This one is the utility function that goes into the decision problem. It's a utility function that gets maximized at the time of decision. The second component of the model states that the decision that the consumer makes, let's denote it by X star of theta, where theta just denotes the environment, the policy, the setting in which the consumer has to make decisions, is always the result of maximizing over X the decision utility over X, sorry, this is du, decision utility over X, subject to the feasibility constraints in the environment theta. So theta, for example, may be buying freely at a particular price, and then the feasibility constraint is just how much you get to consume of X and M, given that the price is P as a function of X. You know, it's kind of the budget constraint that we have been talking about. Now we can also define X optimal of theta, which is the result of maximizing over X U, not of decision utility, but of experience utility over X, subject to the same feasibility constraints. Notice that these are 2 different objects. This one is the one that maximizes the experience utility. In contrast, this one is the behavior that is consistent with the maximization of the decision utility function. Now, based on this, with this object, we can talk about what rationality and mistakes are. So 3, rationality means, or rational behavior, that the decision utility that gets maximized is actually the experience utility. The subject is making choices in the model by maximizing the actual experience utility function that generates its well-being. In contrast, irrational behavior or mistakes can be defined as a situation in which the decision utility function that gets maximized is different from the one that determines well-being. And this is important because notice that when you maximize the same utility, the decision utility function that is equal to the experience utility function, you get that the behavior that is chosen is the optimal one. In contrast, if what induces the behavior is the maximization of a problem that is based on a decision utility function that need not be the one that induces behavior, then you can have that the choices that you make are not the same choices that are optimal. You can have a gap between the two, and we're going to see concrete examples in a moment. Before I move on, I want to highlight one aspect that is very important and that sometimes causes confusion in especially beginning students of economics. Now, we are writing all of these models by assuming that the behavior, the choice x star of theta that gets generated is consistent with the maximization of this decision utility function subject to some feasibility constraints. We have been doing this since Unit 1. Sometimes people think that, therefore economists think and are assuming explicitly that people make decisions by explicitly maximizing a utility function, in this case a decision utility function. That they sit down and think about the different utilities and they weigh the pros and benefits in their heads, and that's how they choose their optimal behavior. That assumption is not part of the theory. This is a theory that is based on what is called an as-if model or an as-if idea, which says that the behavior is chosen as if it was maximizing this decision utility function. That's the only assumption in the model. But the model is not really positing what's going on inside the head. It's quiet about it. As long as the x star of theta that gets generated is consistent with the decision utility function, that behavior is consistent with the model, even if explicit maximization never took place in the head of the consumer. Let's look at a concrete example to make these ideas more precise. So suppose that you are looking at a consumer that is freely trading at price P, so trade at or buy at price P, buy freely at P, and the true experience utility function of the individual is 2a square root of x plus m. However, the individual is going to make decisions by maximizing a decision utility function that looks like this, 4a square root of x plus m. Notice the difference between the two utility functions. Basically, the consumer is exaggerating its benefit function by multiplying it by a factor of 2. Now, what is the optimal behavior here as a function of P? That can be obtained by maximizing over x greater or equal to 0 the experience utility function, which is 2a square root of x plus w minus px. This is a constant. We take it out. We have seen this functional form a ton of times before, this maximization problem, so I'm going to skip it. Skip the details. You can go back and see it or do it explicitly if you want more practice. But basically from that you get that the optimal at P is equal to a squared over P squared. As a side comment, notice that this was also the demand at P in the previous model, which is not surprising since in that model we were assuming that decisions were made by maximizing the true experience utility function, and therefore the behavior and the optimal choice have to be the same. Now, the question is, of more interest is, what is the behavior in this case? What is x star of P? Well, that is going to be obtained by maximizing over x greater or equal than 0, not the true experience utility function, but the decision utility function that is active, which is 4a square root of x plus w minus px. That takes out. And if you do the math, that's going to give you x star of P equals to 4a squared divided by P squared. Okay? So notice that there is a gap, a difference between what gets chosen and what is optimal. These are not the same. In particular, the individual ends up choosing 4 times more of x than is optimal. And the reason is because it's making decisions by weighting the taste parameter more when it makes choices than when it experiences welfare. So this is a clear example of mistakes by the consumer at work. Now, notice three very important remarks or results that are arising from everything that we have discussed. The first is that if the benefit function x that are part of the preferences or the utility function that gets maximized, i.e. the decision utility 1, is different than the benefit function x that determines the level of experience utility up to a constant. So if we cannot write the decision utility benefit function as the experience utility 1 plus a constant, then there is a mistake. Mistakes arise. And we just saw an example of this previously. Second, if there are mistakes, then two things are true. The utility function that is inferred or recovered, actually let's say recovered to be consistent with the language, that is recovered from the data is different from the utility, from the experience utility function. It's not the true preferences that determine the well-being of the consumer, and also because of this, the implied consumer surplus function is also incorrect. In other words, we have been doing these exercises in which I don't have to know the utility function of the consumer. All I have to do is look at their behavior, and from that I can recover their utility function or do calculations about consumer surplus. You have to be extremely careful. If you think there are mistakes, the consumer surplus that you infer or the experience utility function that you recover using those methods are going to be wrong. And because of that, and this is the third remark, it's critical to know if there are mistakes in the domain of application. So you always have to think when you are applying the tools that we have seen so far, are we in a domain, let's say like the choice of dishwasher detergent, in which is very unlikely that you're making mistakes, that you are maximizing the wrong utility function, or are you in that domain like the applications that we're going to see in a second, and in the problem set like addiction or marketing, in which decisions may not be consistent with the maximization of the experience utility function. If you are in the one in which no mistakes apply, then the previous tools that we have seen work well. If you are in a domain in which mistakes are likely, you have to be careful, and the next example that I am about to do explains that in more detail. To demonstrate this issue, let's continue working with the example that we saw a few minutes ago, in which there was a gap between the decision utility and the experience utility function given by that. And remember that we derived that the behavior of the consumer when he maximized the decision utility function was going by this formula. We just need that. So what we want to know is whether or not using the standard analysis of going from preference to consumer surplus gives you the right answer. So suppose that we do that. So suppose that we assume that there are no mistakes. We look at this behavior and we say, okay, the demand function is given by x star of p equals 4a squared over p squared. Now recall that that means that the inverse demand function is given by 2a over square root of x. And we say, okay, given this, let's estimate the consumer surplus at any p, and I'm going to put EST for estimated, which is simply going to be equal to that area. And that is going to be, this is p, this is the demand, the observed behavior at p. So it's going to be that area, which is the integral from 0 to the observed demand, which is 4a squared divided by p squared, of what? Of the area between those two curves, the observed inverse demand function and p. So of 2a over square root of x minus p dx. Now, I'm not going to do the math to save time, but if you carry out that integral, you're going to find that the estimated consumer surplus is 4a squared divided by P. Now, that's what you would estimate if you thought that the consumer was making no mistakes. But what is in reality the true consumer surplus for the consumer? Remember, we can go back to the basic definition. That's going to be the utility given by the experience utility at the point that it consumes minus the experience utility of no trade. And if we substitute, that is going to be equal to, we have to use the experience utility function, 2a square root of what it chooses, which is 4a squared divided by P squared, plus whatever it consumes of M, which is W minus P, 4a squared P squared. This is how much it buys. So this first term is that term, minus the utility of no trade, which is 2a square root of 0 plus W minus P times 0. So this is 0. This cancels with that, and we get that the true consumer surplus is that, but if you do the math, that is equal to 0. So this is beautiful. In reality, given how the subject is behaving, its true consumer surplus, as measured by its true experience utility function, is 0. But if we ignore the fact that the consumer was making mistakes and therefore was choosing a behavior that was higher than optimal, and we just take that data to infer the consumer surplus, we end up overestimating the consumer surplus. So the lesson is very clear. If the assumption that the consumer is making choices in a way that is consistent with maximizing its true experience utility function is correct, then the standard tools apply, and we can do this kind of exercise and get the right answer. But if there is reason to suspect mistakes, that the consumer may be acting as if he was maximizing a decision utility function that is not the experience utility one, then you have to be careful, because this may give you incorrect answers.